Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to look at writing a script or an M file for using the Newton method to solve an equation. So last time we looked at several different ways that we could create a function. So let's use the anonymous version right now. And we're going to look at the function x cubed minus 5. So my variable is x, and it's x cubed minus 5. Okay, so as I say, function handle with values. All right, and then I want function derivative is going to be, well, it's still a function of x, but this time it's 3 times x squared. All right, so I have my functions f and fd described. Okay, now if you'll recall that Newton's method says that I want to start with the value of x, so x equals, let's say, 1, and x equals x minus f of x over f derivative of x. Okay, and I get that, and I could just copy that and paste it and keep doing this until it appears to converge. Now notice that I've only got 5 digits showing there, so again we can expand that view by switching our format to long. And now I see that it actually is still changing, but now then it's not changing anymore. So I could do that. But frankly, sometimes they don't converge in just 2 or 3 steps. Sometimes it's like 20 or 30 steps. I really don't want to have to do it that way all the time. So what we're going to do is we are going to keep our functions, okay? But we're going to create a new script. So new script, and this is going to be a Newton program. Okay, so in this function I want to again tell it I'm starting with a function, and x is, we're looking for the x value, right? So that makes more sense. So my Newton function f derivative, starting value, and a number of iterations. Okay, now I'm going to start by setting x equal to my starting value, and then I want to have a loop. So if you watched this stuff for the other lessons on how the Newton's method works, I need a loop in here. And so for I equals 1 to n, and we use a colon to represent that we're spanning that space, x is equal to x minus f of x over f derivative of x. Now I need to end that loop, and I do like the fact that it sort of lets you know that you're trying to end things, and so I will end those 2 things. Okay, so now then if I wish to come back down here, I want to, I need to save this, excuse me. Oh, that was going to be bad. Save, and I'll save it as my Newton. Save, it's over there. And now when I come in and let me, wow, just close that, I don't need that. Okay, so I have cleared that, so I'm going to enter my function. So let's just do function equals 3 times x squared. No, my function was x cubed minus 5, and deriv is 3 times x squared. And now then I want to call that new function I created. Now this one had a lot of arguments. So my Newton of, not equals, my Newton of, and I want my function, the derivative, my starting value, we'll put in 1, that's what I was using, and let's say we're going to do 10 steps. Okay, and it shows me all of those same numbers that I had there. Now, if you look at these, you can see that I'm no longer really getting change after this one, so I could have just as effectively said 1, 2, 3, 4, 5, 6 terms, and it would have gotten me the same answer. It wasn't really changing after that based on the precision of the program. Let's come down here. So I could have used fewer terms and it would have returned the same answer because that was where it stopped. But I also could have started with a different starting initiation point. So let's try starting at 0. Now, if I start with 0, I'm getting this gibberish, NaN, okay? And the problem is, remember what the formula is, x minus the function divided by the derivative. And once the derivative had a value of 0, then the function fails. So I do not get an answer on this one, I get NaN. And so all I need to do is change the initiation point until I get something that works. I could have saved myself that trouble by looking at a plot first, or I could just randomly try numbers. I guess that's certainly a way to do it. What we're going to do in our next video lesson is we're going to look at how I can have an error or a precision estimate, okay? And so we're going to start looking at adding a tolerance in. Thank you very much for your time.